Thank you and God bless. So let's get started. Number one atmospheric pressure is equals to, remember, I have told us this in the part 1 of this class, that whenever you're giving pressure and you want to use pressure, you must convert the pressure to Newton per meter square. Remember when we dealt with adiabatic processes, we said that 1 atm is equals to 101, okay, 325. You can check that out in the part 1 of this class. Okay, we'll go to question number 2 quickly. The isothermal pressure of a gas is 300 Newton per meter square at the temperature of 30 degrees centigrade. Determine the isothermal bulk modulus of the gas. Now, what we ought to know here is that isothermal process is simply a process of constant temperature. Remember we talked about adiabatic in the part 1. Adiabatic. This is a system of constant heat. There is no heat gain, there is no heat loss. Now, this one is talking about isothermal. An isothermal system or process is a system or process of constant temperature, constant heat, constant temperature. Now, when we talked about the adiabatic system, we saw the adiabatic bulk modulus and its relationship with adiabatic pressure. We said that for adiabatic system, adiabatic bulk modulus K is equals to adiabatic pressure times Y. But in isothermal system, isothermal bulk modulus is equals to isothermal pressure. Is equal, directly proportional, equal. So mark these two expressions, that adiabatic bulk modulus K is equals to P times Y, where this Y is Cp over Cv. But for isothermal bulk modulus K is directly or is equal to isothermal pressure. There is nothing. So if you know the isothermal pressure, it is the same as the isothermal bulk modulus. Okay. So in this case, K is equals to P. K is equals to P. So let's go back to the question and see what the question was saying. He said the isothermal pressure of a gas is 300 Newton per meter square at a temperature of 30 degrees centigrade. Determine the isothermal bulk modulus. Now, they gave us the isothermal pressure P as 300 Newton per meter square. 300 Newton per meter square. This is the isothermal pressure. So they asked me to calculate for the isothermal bulk modulus. Remember that isothermal bulk modulus is equals to isothermal pressure. So the same answer will be 300 Newton per meter square. So the answer is still 300 Newton per meter square. That will give us option B. We go to the third one. A tangential force of 70 Newton applied on a solid of cross-sectional area 20 centimeters square caused a deformation through an angle of 0.03 degree. Calculate the shear modulus of the elasticity of this solid. Remember that this is modulus of rigidity. We saw that in part 1, which is 2020-2021. And we said that modulus of rigidity G is equals to F over what? A theta. Remember this formula, or you go back to the first part. These are questions that are being repeated. Okay. The only difference here is that the angle of that other one was 0.07, while this one is 0.03. So I believe by knowing the formula, that is clear. Number 4, example of viscous liquid is, remember in part 1, we talked about viscous liquid. We say viscosity of a liquid is that force that acts between the layer of fluid. That force that acts between the layer of fluid that prevents one to slide over the other. In a nutshell, we say that viscosity of a liquid is that force that prevents the liquid to flow. We say that liquids that does not flow very well are said to be high viscous, while the ones that flows regularly are said to be low in viscosity. Now, example of liquid that have high viscosity, we say grease. We mentioned grease. We mentioned honey. Original one, no, not as fake ones you see in the market. Original one, honey. Honey is very thick. We saw grease. We saw honey. Now, what of fluids or liquids that does not have viscosity? Number one, we talk about water. What about kerosene? We talk about petroleum. All these ones, they flow so fast. Hope you understand. So they are very low in viscosity. So coming to this question, it says, which of the following example of viscous liquid? Kerosene, yes. Petroleum, yes. Engine, example of viscous liquid, no. Example of viscous liquid, kerosene is not viscous. Hope you know. Petroleum is not viscous. It has a very low viscosity. Engine oil, yes, very high viscous fluid. So engine oil becomes the answer to this. Number 5, which of the following are used in dimension in physics, in mechanics? Which of the following are the 3 basic dimensions in physics used in mechanics? Remember that we said that when we come to fundamental quantities, we have length, we have luminous intensity, we have mass, we have temperature, we have amount, we have electric current, One, 2, 3, 4, 5, 6. It's a local mistake. D. Okay, we have temperature, we have time. Okay, there are 1, 2, 3, 4, 5, 6, 7. These are the fundamental quantities. Now, I want you to know something about fundamental and derived quantities. What makes a fundamental quantity a fundamental quantity? It is SI units. These ones that we have listed here are called fundamental. Why? Because their SI unit is unique to them. They didn't borrow it. Why the derived ones? Their SI unit was borrowed from the fundamental. Let me take an example. The unit for this is meter. The unit for this is candela. The unit for this is kilogram. The unit for this is Kelvin. The unit for this is mole. The unit for this is ampere. The unit for this is seconds. Now, these units are unique to these quantities. But let us take one or two derived quantities. Let's look at velocity. Let's look at force. Then let's look at momentum. Now, velocity is meter per second. If you observe, and force is meter, okay, kilogram meter per second square. Then momentum is kilogram meter per second. Hope you know. Velocity is mass over seconds, or mass meter per seconds. Now, watch something now. Meter belongs to length. Seconds belongs to time. So this velocity borrowed meter here and borrowed seconds here to make its own unit of measurement. And that is why it's called derived. Look at force. Remember that what we call force is Newton. And you know that force is MA. Mass is kilogram. Acceleration is meter per second square. So that thing we call Newton is also called kilogram meter per second square. Now look at it. Kilogram is borrowed from mass. Meter is borrowed from length. While seconds is borrowed from time. So it's a derived quantity. Here, momentum. Remember, momentum is mass times velocity. Mass times, so mass is kilogram. Velocity is meter per second. And that's what we have there. Kilogram is borrowed from mass. Meter is borrowed from length. While seconds is borrowed from time. These ones are derived. Why these ones are what? Fundamental. They are fundamental because other physical quantities borrow their SI unit to make up their own. So these are fundamental. Now, when we come to fundamental quantities, 3 out of these fundamental quantities are called basic fundamental. Which of the 3? The length, the mass, and the time. So we call them L, M, and T. These 3 are basic fundamental. Should they ask, which of the following is basic fundamental? Look at them. L, M, T, length, mass, and time. They are basic fundamental. If you may be asked, why are they referred to as basic fundamental? They are referred to as basic fundamental because every other quantity can be defined based on their 3. Every other quantity can be defined based on length, mass, and time. Every other quantity can be defined based on length, mass, and time. And that is why they are called the basic fundamental. And whenever, I repeat, whenever any physical quantity is defined based on length, mass, and time, that expression is called dimension analysis. When you express or you define a physical quantity using length, mass, and time, what you are doing is dimension analysis. So going back to the question now, that is question number 5. Which of the following are the 3 basic dimensions in physics? Okay, look at them. It is length, mass, and time. Let's see the options there. Time, we have time there. Mass, length, that is time. Yes, that one is there. Electric current, temperature, intensity, no. Time, temperature, and mass, no. Length, width, and no. So option A is the answer there. Let's go to question number 6. Which of the following quantity is not? So he said, which of the following quantity is not a vector quantity? Remember that we have said, discussed in part 1 of this revision class for Physics 101, that vector quantities are those quantities that have both magnitude and direction, while scalar quantities are those ones that do not have magnitude and direction. One thing you must know in vector and scalar is that, one is that there is this thing called displacement. And in brother is called distance. There is another one called velocity. In brother, na they call speed. Now, the difference, if you watch, displacement and distance are the same. Why? Because they are measured in meter, and it's measured in meter. Velocity and speed are the same. Why? Because they are measured in meter per seconds. But the actual difference between displacement and distance and the actual difference between velocity and speed is that displacement is a vector quantity. All these ones are vectors. Why these ones are scalar? Note that. Displacement is a scalar quantity. Velocity is a scalar quantity. Displacement is a vector quantity. Velocity is a vector quantity. Distance is a scalar quantity. Speed is a scalar quantity. No wonder when you want to define this velocity, velocity is displacement over time. Velocity is displacement over time, while speed is distance over time. Please note that. Velocity is displacement over time. That makes velocity a vector quantity. While speed is distance over time. So going back to the question number 6, which of the following quantity is not a vector quantity? Displacement. Displacement is a vector quantity. Momentum. Momentum is a vector quantity. Speed. Speed is not a vector quantity. Why is momentum a vector quantity? Because momentum is mass times velocity. Velocity is already a vector quantity, which makes momentum a vector quantity. Are you there? Speed is not a vector quantity. Speed is not a vector quantity. Okay? Then we have force. Force is a vector quantity. Why? Because force is weight. Weight has direction. Weight acts downwards. So weight is force. Force is weight. And it is a weight, a force that is acting downward. So it has magnitude and it has direction. So we move to question number 7. Or see, when a unit mass of a liquid is converted into vapor at its boiling point without a corresponding change in temperature, then the quantity of heat required to do that work is called, remember in part 1, we talked about this, moving from liquid to vapor at constant temperature. Moving from liquid to vapor at constant temperature, it is latent heat of vaporization. Remember, when we saw it in 2020, we found out that the option was not there. Now they've corrected themselves. The option is now specific latent heat of vaporization, option B. So if you see it in the exam, remember, moving from liquid to vapor is specific latent heat of vaporization. Moving from solid to liquid, moving from solid to liquid is specific latent heat of fusion. Why the energy required to raise the temperature, a unit mass of a body by 1 Kelvin is called specific heat capacity. I believe we did this very well in the part 1. You can go back to the video to see that. So we'll continue. Question number 8. Or see, the quantitative relationship between heat and other forms of energy is called thermodynamics. Thermodynamics is what tells us about heat and other forms of energy. Then we look at question number 9. In the expression Q equals to mc theta, Q equals to mc the theta. Now remember that this is specific heat capacity. This C here is specific heat capacity. M here is mass. Theta here is temperature. YQ here is heat gained or lost, quantity of heat. Okay, so this is quantity of heat gained or lost, mass of the body, specific heat capacity, and temperature. So what is the question? Say the quantitative relationship between heat and okay, no. In expression Q equals to mc theta, Q is heat capacity, no. Latent heat, no. Specific heat capacity, no. Quantity of heat gained or lost, yes. Quantity of heat gained or lost, mark that. Quantity of heat gained or lost. So remember I told you that if it were to be latent heat of fusion, we have that Q is equals to ml. Don't forget this. We said that in part 1. Okay. Question number 10. Which of the following statement is not correct? Vibration motion that is maintained by a restoring force only is called free vibration. Yes. Vibration, I explained this very well in part 1. That vibration motion that is maintained by only the restoring force, it only maintained by a restoring force, is called free vibration. When a periodic force is applied to the system, the resulting vibration motion is described as forced vibration. Yes, option B, true. When you now apply a periodic force to that motion or that vibration, you call it a forced vibration. Why? You are forcing that vibration to continue by applying force. Like a boy that is on a swing and the boy is swinging. If you allow that swing, the boy goes up, comes down, it goes up, comes down. If you allow it, that jangolova or swing will definitely come to rest after a time. But if you don't want it to come to rest, you have to apply force periodically. When you push it, it goes up, it comes down, you apply another force. You have to keep applying. You are forcing that vibration. That's what we call forced vibration. Option C, it says the vibrating system, okay, the vibrating effect of friction on that by neglecting it. Okay, like I said, when you neglect the frictional force, when you neglect, I say that remember we said that when you have a simple harmonic motion that is in process, it will definitely come to stop. Why? Because of frictional force that is acting on it. So when I set up a simple harmonic motion to move, like I set up that boy or that baby on the swing and allow it, that swing will definitely come to rest. Why? Because I know that frictional force is acting on that vibration or on that simple harmonic motion. But then, if I decide to make calculations without considering frictional force, you will see that I'm trying to remove frictional force in my own calculation. It means that that vibration or that swing will never stop. But if I consider frictional force, then that motion will what? Stop. So you see that option D becomes the final answer. Okay, we continue. Question number 11 says, which of the following pair of equation is correct? Which of the following pair of equation is correct? So if you watch, that thing deals with is dealing with simple harmonic motion. So I would like us to take a very little class about this question number 11 and simple harmonic motion. Okay, remember that I said in part 1 that when you come to simple harmonic motion, SHM, there are two types of systems. We have the mass spring system. We have the mass spring systems. Now, when you come to the mass, we have the mass string, or you can call it rope system. So these are the two types of system we have there. We were meant to see formulas that relate to the mass rope system. Under there we saw that angular velocity is given as root of g over L for this one. We also said that frequency is given as 1 over 2 pi root of g over L. We also learned that period is 2 pi over W, or it is 2 pi root of L over G. Watch, it is upside down so that you will know. This is G over L, this one is G over L, while this one is L over G. So having known this, we want to now see as it relates to mass spring system. We want to now see as it relates to mass spring system. For mass spring system, remember that we are making use of spring, something like this. So there is always a spring constant. There is always a spring constant. So for mass spring system, my W is equals to root of K over M. Look at the mass rope system. Look at the mass spring system. My F is equals to 1 over 2 pi root of K over M. Then my T is equals to 2 pi root of M over K. Okay, you can see the difference. The difference is just there in that this is G over L. Why are we having L? Because of the rope, length of the rope, length of the rope, length of the rope. Then acceleration due to gravity, acceleration due to gravity, acceleration due to gravity. Just like you told us, it is the one you did in your physics practical. You tie a rope to a bulb and you allow it to swing. Okay, but for the mass spring system, the spring used to have what we call a spring constant. So the mass of the body now for W is K, which is a spring constant over M. F is K over M, almost the same thing, but instead of G now we have spring constant. Here we have gravitational constant. Here we have spring constant. Here we have length of the rope. While here we have mass of the solid. Here we still have 2 pi. Instead of L now we have mass. It is also upside down. Do you see it? Only I'm not in the upside down, just the way it is upside down here. Now, having known that, now we will look at motion in a system. Now, first of all, velocity. You remember that this is a simple harmonic motion. For a simple harmonic motion, the velocity is calculated as plus or minus angular velocity equals to a square minus x square. A square is the amplitude, while x is the displacement. Some textbook will represent amplitude as this, so their own will now be this. Also, maximum velocity. When will there be maximum velocity? Maximum velocity occurs when the displacement is equals to 0. That is when the body is at equilibrium position. When the body is at equilibrium position, it means that x is equals to 0 when the body has not been displaced at all. The maximum velocity, if x equals to 0, if you put it here, then you say that maximum velocity is calculated as plus or minus wa or plus or minus wxm if you are using this as your amplitude, or if you are using a as your amplitude. The next one is acceleration. Definitely where there is velocity, there is also acceleration. So acceleration equals to w square x. W square x. X is displacement. Okay, maximum acceleration, which will occur when amplitude is equals to displacement. When amplitude and displacements are equal, then maximum acceleration produces w square a, or that is minus w square a, or minus w square xm, whichever one you are using as your amplitude. And if it is a is your amplitude, good. If xm is your amplitude, good. Okay, the next thing we're going to go into is energy in a system. Do you remember that there are two energies in the system? There is kinetic energy, there is potential energy. Then kinetic energy plus potential energy will give us the total energy in the system. So let us see how that is being done. Now, if we look at the board, energy in the system, we have potential energy. It's given as half kx squared. Watch, this x is not the amplitude x, it's just the other displacement x. Kinetic energy is given as half mv squared. This v is not the maximum v, is the normal velocity. Therefore, E, total energy in the system, is given as potential energy U plus kinetic energy, and it will give us half Ka squared. This A is amplitude. Watch it again. If you're using A or you're using this. So these are energy that is in the system. So the total energy in the system is the potential energy plus the kinetic energy, and it's equals to half Ka squared, or half Kx subscript m squared. Now we're going to take one question to drive all these points home, a question that will ask us about all these things, so that when you see it in the exam, you'll be able to. If we take a great look at the question on the board, it says, consider a spring of spring constant this, on which a mass of this is suspended. If the body of mass is released from rest at this, so this become my x, this become my x, not my amplitude. It's released from rest at this. That means, let's take, you are doing your practical, you hold the ball and you take it to 0.2 m and you release it. At that point, remember, see something. Now, okay, I'll still come back to that. It's released at rest at this, okay? Calculate the velocity, the acceleration, the velocity maximum, the acceleration maximum, the potential energy, the kinetic energy, and the total energy in the system. Now, what's something? This value of x, this is your simple pendulum. You raise it to 0.2. That is the maximum displacement you did. And at maximum displacement, we call it what? Amplitude. So this is my amplitude. Amplitude is maximum displacement from the point of equilibrium. This is my point of equilibrium, a point of rest, and I displayed it to 0.02 m, and that is the highest I have displaced it. Then that is where I left it. When this thing starts swinging, when it gets to this point, it will return back. It will not pass this point. Meaning that this point is my what? My amplitude. Okay. So we are going to be solving one by one. We have solution. The first one says we should solve the velocity. Remember that velocity is w root of xm squared minus x. Okay, w root of xm squared minus x. Okay, so the question say we should solve for, let me get it again. Okay, there is something I omitted in the question. So the question says we should calculate for velocity at halfway, acceleration at halfway, velocity maximum, acceleration maximum, potential energy, kinetic energy, and total energy in the system. So this is our, like I said, this is our amplitude. So we have to calculate velocity halfway. As this thing don't reach here now, it's coming back. If it gets to halfway, from here to here is 0.2. Half of it will be 0.02 divided by 2. So solving this now, I have my W. I need to calculate for W. Remember that my W is root of K over M. Then root of, let me use A here, A squared minus X. This will produce me, K is 200 over M, which is mass 0.05. And this is the, then times root of amplitude is 0.02 times halfway now. The displacement halfway 0.02 all over 2. Now, if you do this very well, from my point of view here, this is all squared and this is all squared. Then this will produce velocity of plus or minus 0.35 meter per second squared. Hope you understand that. So to calculate the velocity at halfway, half of this, we have W this, then W is this, because this is a mass spring system. So we have this for W, A squared minus this. We got our amplitude as this. Then having done this and do this, you're going to get the velocity to be that. The next question says we should calculate the acceleration halfway. So remember that acceleration is equals to W square X. W square X. So W is already root of K over M, which is K is 200 and M is 500. So all this will be squared times X halfway 0.02 over 2. By the time you multiply these two together, you are going to be having 4 meter per second square. By the time you multiply these two together, that is the acceleration of that system. Then the next one says we should calculate maximum velocity. Remember that maximum velocity occurs at equilibrium position. That is the position where our x is equals to what? 0. So we are going to be saying V maximum is equals to plus or minus WA. You remember that? So that we have plus or minus W is root of 500 over 200. Then times amplitude, which is 0.02. And if you do that very well, press your calculator very well, you are going to get 0.4 meter per second. That is the maximum velocity. Then the next one we also to calculate for maximum acceleration. A maximum, which we know it occurs when xm is equals to x, or amplitude is equals to displacement. And this will give us minus W square xm. W square xm. So this will give me minus W is root of 500 over 200. Spring constant is 200, sorry, not 500. 200 over the mass of the body, 0.50. When you have done this for W, then you multiply it by 0.02, which is the amplitude, or this can be written as minus W square A. Hope you know. So this one is squared. By the time you multiply these two things now, you are going to be having 8 meter per second. 8 meter per second square. 8 meter per second square. So this is the maximum acceleration. Now, some might ask, why is the minus not appearing? The minus may not appear in the final answer because it is not a numeric minus. Okay. Then the next thing we are talking about is potential energy. Potential energy. Remember that potential energy U is half kx squared. Potential energy U is half kx squared. So we have half times 200 times x. X is halfway in this question. X is halfway. 0.02 over 2 all squared. Then you are going to get your what? Potential energy. And this will give you potential energy according to what I have here is 0.01 joule. That will give you 0.01 joule. That's potential energy. The next one we have to calculate is for kinetic energy. Kinetic energy. Remember that the kinetic energy is equals to half mv squared. This v is velocity, not maximum velocity. And remember that we have calculated for the maximum for the velocity. So times mass, which is 0.50, times my velocity, which I have calculated before to be 0.35. 0.35. I square it. If you press this well in your calculator, you'll be having 0.03 joule. That will become the kinetic energy of that system. Now, the total energy of the system, total energy, which is we call E. Remember, total energy is potential energy plus kinetic energy. So potential energy we got was 0.01 plus 0.03. And that will give us 0.04 joule. That is the total energy. Also, you can calculate the total energy E as half, half K A squared. So if you do that, we'll be having 0.5 times K, which is 200 times amplitude 0.02 all squared. If you multiply this, you have 0.04 joule. So it's either you calculate for the potential energy separately, you calculate for kinetic energy separately, and you get them. If you add them together, it will give you total energy in the system. Or you use this formula using the A amplitude to get the total energy in the system. So you now agree that the total energy in a system is U plus KE. It's U plus KE. Look at it. It also appears here. So with this, I believe that we have got some information about simple harmonic motion. So we go back to the question and see what the question wants us to answer. Now, still on question number 11, we say, which of the following pair of equation is correct? Option A, V, that is equation for velocity of the system. V equals to plus or minus W xm squared minus A squared. No, remember that I said xm and A are the same, so that's not true. B plus or minus W xm squared minus x squared. That is correct. What of for the acceleration? W square x is correct. Let's see the option C. There is no W in option C, making it wrong. Option D. Option D. There is no minus in the acceleration, making it so we are going for option B. Remember that option D, if you have minus W square xm or minus W square A, that is for maximum acceleration. So option B is the most correct. If you're still finding it difficult, go back to the calculations we have done. We solved all those things one by one, and you see how the formulas appear. Number 12, the rate of change of angular momentum of a particle is equals to torque. We have said that torque is equals to dl over what? dt. Torque. Go back to part 1 of this lesson. Okay. Number 14, kinetic energy of a particle of mass m and speed v is defined as half mv square. So option A. Number 15, centripetal force required to maintain car moving round a circle track is supplied by friction in the wheel. Friction in the wheel. If there is no friction in the wheel of the car, there is not going to be even, the car cannot even move in the first place. So it's supplied by the friction in the wheel. Okay. Number 16, compute acceleration of a lorry which started from rest and accelerated. Okay, let's see this. This is uniformly accelerating motion because they've said we started from rest. Okay, look at the question again. It says compute the acceleration of a lorry which started from rest. That means u is equals to 0 meter per second. We started from rest and accelerated uniformly until it attains a velocity of 2 meters per second. It accelerated uniformly until it attains a velocity of 2 meters per second. Then I say in 5 seconds, they're giving me t, 5 seconds. Then the answer I should calculate, compute for the word acceleration. You remember that in uniformly accelerating motion, we have that A is equals to V minus U over T. This is the question that has all these parameters. So if you put everything here, you are going to get the value of A. Then is question number 17. Question number 17 has been treated in part 1. So go to part 1 and see what I said about it. Question number 18. The term unit is defined as standard used to describe physical quantities. Yes, this is standard quantity used to observe the world around us. No. Option C say a fundamental standard of measurement. Fundamental standard of measurement. Keep that. We are going to compare it with option A. Option D says to measure the normal distance. No. So it is between option A and C. So let's examine them very well. Option A says a standard used to describe physical quantities. It's used to describe physical quantities. Why option C say a fundamental standard of measurement? I think option C is more correct. SI units are for measurement, not used to describe. They are used to measure. So I think we should go for option C. Option C is more correct. So that is question number 18. We go to question number 19. One of the following is a dimensionless quantity. Dimensionless quantities. How do we have dimensionless quantities? I believe we have learned about dimension. You can write out dimension of as many as physical quantity that you are being asked. Now, some quantities are said to be dimensionless. These quantities are the quantities that have ratio of 2 units. Example, strain is an extension over length. This extension is measured in meter. This one is measured in meter. Meter cancel meter, and there is no dimension. Now, listen to this very important information. For you to be able to give dimension of a physical quantity, it must be based on its unit of measurement. Meaning that any physical quantity that does not have unit of measurement might not be able to be dimensioned. So, let's see. Velocity has unit of measurement, option A, so it must have dimension. Tensile strain has no unit, so it may not have dimension. Volume has unit, so it will have dimension. Mass has unit, so it will have dimension. The answer to that question is strain, option B. Option 20, question 20, the standard blood pressure of a normal man is being, remember in section part 1 of this class, we said it is 120 over 80. This is systolic and this is diastolic. Go back to that question and we said that so well. Number 21, a man weighs 80 Newton in air and weighs 65 Newton in water. What is the upthrust on the man in water? Now, remember that I said upthrust is equals to apparent weight. And apparent weight is weight in air minus weight in water. If you apply that, you are going to calculate what they want you to do there. We have discussed that in part 1, 2020-2021 question. You can visit it again. Number 22, it says adhesive liquid. Yeah, we have talked about, I don't even want to go much into it, but we have talked about adhesive liquid and also cohesive liquid in 2020-2021. Number 3, a slope of distance time graph and velocity time graph. Let's see something there. Slope of distance time graph. Let's see. This is my graph. Then we have distance. And we have time. And we have another graph. Velocity. And we have time. Now, if I take this slope, remember your slope is the y. Change in y over change in x. That is the y over what? The x. So, but here my x is time and my y is this displacement. So, it's going to be change in distance over change in what? Time. That is my slope. Here my slope will be change in v over change in t. Now, change in displacement, or you call it distance over time, will give you velocity. Do you remember that? Why change in velocity over time will give you acceleration. Acceleration. So the slope of distance time graph will give you velocity, while the slope of velocity time graph will give you acceleration. So find out your answer there. Okay. Number 4, the process by which heat is transmitted from one body to another without heating up the intervening medium is called, let's take a little class on convection, radiation, and all those these things. So take your pen and write. Conduction is the mode of transmission of heat in which, I'm talking about conduction now. Conduction is the mode of transmission of heat in which heat travels from hot part of the body to cold part of the body without any actual motion of the heated particle. Without any actual motion of the heated particle. Example, when a spoon is used to turn hot soup, provided the spoon is a good conductor. So, in this case now, the mode of transmission heat is in which heat travels from hot part of the body to a cold part of the body without any actual motion of the heated particle. That is conduction. Let's see convection. Convection. This is the process of transmission of heat from one part of the medium to another by the bodily motion of the heated particle. When the heated particle actually move, we call it convection. Okay? It is possible only in liquid and gas. Convection is possible only in liquid and gas. Okay? The last one is radiation. This is the only process of heat transfer. This is the only process of heat transfer that travels through a vacuum. Radiation travels through a vacuum. Hence, it is defined as the process by which heat is transmitted from one body to another without heating the intervening medium. Without heating the intervening medium. In radiation, the heat will travel from body A to body B without hitting the intervening medium. So we have seen that radiation is, we have seen what radiation is, we have seen what convection is, and we have seen what conduction is. So let's look at the question and see what the question have for us. It said the process of which heat is transmitted from one body to another without hitting the intervening medium. My brother, that thing now waiting is that thing should be radiation according to what we learned here. So let's look for option having radiation, convection, conduction, radiation. Option C, radiation is the answer. Number 5, he said the total energy in a simple harmonic motion is given as half k x m square. Half k x m square. If you are using xm as your amplitude, or half k a square if you are using a as amplitude. Okay, I think we have discussed that very, very well. So option A is very correct here. Option A is very correct here. Another one that is correct here is option C. Half kx squared plus half mv squared will give you total energy. Yes, total energy is okay. The question says the total energy of a system is given as except, okay, the except option A is correct. Option C is correct. Option B. Okay, what's something in option D? Let's look at something in option D. Remember that U is half kx squared and ke is half mv squared. Now watch, the x that is used here is not the maximum x. It's not xm, or is it amplitude? Now the v that is used here is not v maximum. Are you getting that? So that means we are using displacement that is not amplitude, and we're using v that is not maximum. So if we say that total energy becomes half kx squared plus half mv squared. Also, if you decide to use x as amplitude and you decide to use v as maximum, it will give the same result. That means your u becomes half kxm squared. Once you have used amplitude here, just know that when you are doing kinetic energy also, you are going to use half mv maximum all squared, so that this and this will tally. This will also give you total energy is half kx squared maximum plus half mv maximum all squared. This is also correct, meaning that if you are using k, ordinary x displacement, you are using ordinary v velocity. If you are using x as amplitude, you are using v as maximum. So that makes option D correct. So the one that is not correct here is option B, is odd. So that becomes the answer. Number 6, a sprinter of mass 50 kg is running at a velocity of 10 meters per second. Calculate the momentum of the sprinter. Remember that momentum is mass times velocity. Number 7, collision is defined as elastic if, remember we said that a collision is said to be elastic if momentum is conserved, kinetic energy is conserved, and total energy in the system is also conserved. So you can pick up the option there. Number 8, an object of mass 4 kg is acted upon by 2 horizontal forces in the opposite direction. Calculate the acceleration produced by this system. They gave us 2 forces here. The question says an object of mass, we have mass 4 kg, okay, is acted upon by 2 horizontal force. F1 is 8 Newton, F2 is 2 Newton, and they say in opposite direction. Now, when they are acting in opposite direction, you are going to what? Subtract. When they are acting in opposite direction, you are going to subtract. Okay, in opposite direction. Okay, and it said calculate the acceleration produced by the system. We are looking for A. Remember that F is equals to ma. So that A becomes F over m. But then I'm going to get my total F. It's going to be 8 minus 2 in Newton over my mass, which is 4 kg. And this is 6 over 4. This is 3. This is 2, which is 3 over 2 meter per second square. So you can find that in option 3 over 2 meter per second square. Going to question number 9. Calculate the pressure at a depth of 5,000 centimeters in a river with water density of this. Now, to calculate for pressure in a river or in a fluid, you must know one thing, that the depth is pressure is directly proportional to depth or height. Now, it means that the deeper a river or an ocean, the deeper, that is, the more the depth, the higher the pressure. The more the depth, the higher the pressure. That is why the pressure that draws anybody down inside a river, the more the river, the higher the chances of the river swallowing the person, according to what they will say. Smooth. So mathematically, pressure is equal to rho GH. Have this. In fluid, pressure is equal to rho GH, where this is density. This is acceleration due to gravity, while this is depth. So the questions here say we should calculate for pressure. So they gave us density, and they gave us, we have G as 10, and they gave us height as 5,000 centimeters. Remember, they are going to convert that 5,000 to meter. So that question is solved. Number 10, calculate the viscous force of a liquid of surface area. Following the verse, we have done that in part 1 of this class. I've given you the formula for calculating viscous force and even formula for calculating terminal velocity. So go back to that question and you'll be able to recall what we said about this. And this brings us to the end of part 2 of Physics 101 online revision class. That is 2021 through 2022. The next one we'll be seeing ourselves, we'll be studying 2022 through 2023. Please ensure that you take this video serious, practice with it before going for your exam. Don't forget to subscribe to this channel, and don't forget to like every video which you have seen. Thank you and God bless you. I wait for your question at the comment section.